Hey class, today we're going to be talking about the conservation of energy. Yesterday we talked about potential and kinetic energy, the two types of energies, and we're going to see how that goes into the conservation of energy. So here we have a picture of a roller coaster. There's different carts on the roller coaster at different places, and we're asked where is the potential, kinetic, or both. So looking at cart A, it's at the very top of the hill. So we would consider that to have a lot of potential energy because it has a lot of room and space to gain velocity. Looking at B, B is now down the track about halfway. It now is moving with a fast velocity, but it also has more space to gain that velocity. So we would consider that to have both potential and kinetic energy. Looking at C, it doesn't have much potential energy just because there's nowhere for it to go but up. So it has a lot of kinetic but little potential. And then looking at D, it has both potential and kinetic because it's still going to be moving at a velocity, but it also has potential to gain more velocity as well. The law of conservation of energy states that neither energy can be created nor destroyed. It's just going to be transformed into one type of energy, potential, into kinetic, and then back again. So looking at this bike on a hill, as he's pedaling up the hill, he's going to be gaining potential energy. So he's putting energy in to gain that potential, and then as he goes back down the hill, he's going to be turning that potential into kinetic energy. So now we're going to be looking at a word problem and how that can be used for the law of conservation of energy. So I'm going to get a pen here and we're going to solve with it. So we have 50 kilograms as our mass, and the ledge is 10 meters high. How much potential energy does that ball have at the top? So the mass is 50 kilograms. The ledge is 10 meters. And our formula for potential energy is mass times gravity times height. So our mass would be 50. Gravity is always going to be 10 for us, and then the height is 10 meters. So we're going to multiply all that together to get 5,000 joules of potential energy at the top. And then it says, since energy is transformed, how much kinetic energy will the ball have once it's about to hit the ground? So how much kinetic energy would it have looking at this ball at the bottom? So this ball here is the same ball as up there, so as it's hitting the ground, how much kinetic energy would it have? Well, since the law of conservation states that energy is not lost but only transformed, if it has 5,000 joules of potential energy at the top, that means it's going to have 5,000 joules of kinetic energy at the bottom. So that potential energy at the top was transformed into the potential energy at the bottom. So now we have some quick review questions. First one, what does the law of conservation of energy state? Number two, on a roller coaster, where do you have the highest potential energy? Where do you have the highest kinetic energy? 3, define gravitational potential energy. And 4, define mechanical energy. So take some time, try to answer those as best as you can, and then we're going to go over the questions in a second. Alright, so let's talk about those questions. What does the law of conservation of energy state? Energy can neither be created nor destroyed, just transformed into different energies, potential or kinetic. Where is there most potential energy on the roller coaster, and where is there the highest kinetic energy on a roller coaster? That's going to be at the top of the hill for the potential energy and the bottom of the hill for kinetic energy. What is gravitational potential energy? That is energy given by an object when using the force of gravity against it. And then finally, what is mechanical energy? It is the total energy of motion and position of the object. So if an object, for example, is flying through the air like a football, it has velocity, so it has kinetic energy, but it also has potential energy because there's potential for it to gain more velocity. That is it. So we're going to go ahead and look at some more examples. So click on the worksheet provided, and we're going to go over that.